you don't go to sleep looking healthy at night, wake up with a big tumor on your lung or your kidney or something like this. I mean, these things, when you have something that can be obvious now and detected by pathological report or non-invasive imaging, I mean, there's got to be a large number of dysregulated cells in that mass before you actually see it with some diagnostic tool. But, when I wrote my book on cancer, Albert Szent-Györgyi, who was a Nobel Prize recipient, did work on vitamin C. He called this cancer thing an oncogenic paradox. How is it possible that so many different provocative agents could elicit a dysregulated group of cells in a particular organ or part of the body in a common way? What is the common pathophysiological connection among all the provocative agents? Like, we know carcinogens. They call chemicals that cause cancer as carcinogen. This is a chemical that has been determined to cause cancer. So we refer to these chemicals as carcinogens. We also know that we have certain viral infections like hepatitis C, papillomaviruses, and some of these other kinds of carcinogenic viruses. They produce cancer. We also know radiation can produce cancer. We also know that chronic inflammation can produce cancer. We know that intermittent hypoxia can produce cancer in certain cells. What is the common pathophysiological mechanism by which all this happens? We know that there are certain inherited genes in our body. These are called secondary risk. They're not primary risk factors, but they, in the right environment, they will elicit cancer, like the Li-Fraumeni syndrome. You have the BRCA1 mutations for breast cancer. So a woman might get breast cancer for having a BRCA1 mutation. They might get breast cancer from a clogged milk duct. They may get cancer from systemic inflammation. But when you look at it under the microscope, the pathological report, they say, oh, you have breast cancer. So what was the origin? Why all these women that would have various kinds, they might all have different provocative agents that elicited the common pathophysiological mechanism is to all cancers is a chronic disruption of energy metabolism in the mitochondria of the cell, followed by a compensatory fermentation. Now, let me break that down, because this is what Otto Warburg initially said. He just didn't connect all the dots like we have. He said cancer elicits from chronic damage to the ability of a cell to generate energy from oxygen. So we know that all of the cells in our body use oxygen to generate ATP, which is the currency of energy in our body, adenosine triphosphate. Okay. So you and I are breathing, we're talking, because the air that we breathe in has oxygen in it. Oxygen serves as the acceptor of electrons, which allows the mitochondria to produce vast amounts of energy. And the waste products are CO2 and water of oxidative phosphorylation. All of our cells in our body, the majority of cells except red blood cells, are using this process so that we can remain alive. What happens in the cancer cell? Over time, that organelle, that process becomes corrupted or deficient in some way. But as Warburg said, if you disrupt oxidative phosphorylation or energy through oxygen too acutely, the cell will die, and you'll never get a cancer from a dead cell. So whatever causes the cancer, whatever the provocative agent does, it doesn't do it acutely, it does it chronically. Mm. And by chronic disruption of oxidative phosphorylation, it allows the cell to replace oxidative phosphorylation with the ancient pathways of fermentation. The fermentation pathways is energy without oxygen. And all of the cells on our planet existed in using fermentation before oxygen came into the atmosphere. And that was about 2.5 billion years ago. So the cancer cell adapts to a fermentation metabolism as a way to compensate for the chronic disruption of oxidative phosphorylation. Interestingly enough, that same organelle, the mitochondria, controls the cell cycle. It allows the cell to remain in a quiescent, differentiated state. And as that organelle becomes corrupted over time, the transition to fermentation causes the cell to lapse into the default state, which is proliferation. So in this, all of the cells on our planet were highly proliferative, dysregulated cell growth before oxygen came into the atmosphere to form metazoans and more complex organisms. So the cancer cell is doing nothing more than falling back on ancient pathway, living as if it were in the absence of oxygen. And that's what cancer cells do. They can absolutely survive without oxygen. They don't use oxygen anymore. So they're living without oxygen, anaerobosis, as Warburg called it. They're life without oxygen. Even when oxygen is present, the cancer cell is still fermenting. So now you know what this cell is.